In classical electrodynamics, previously we have discussed in very detail the propagation of electromagnetic waves in different media. First of all, you have seen the propagation of EM waves in free space, in dielectric medium, in isotropic and anisotropic dielectric medium, and also in conducting medium. Now it is time to see the application part of this propagation of electromagnetic wave. In fact, the propagation of electromagnetic wave is utilized particularly in radio communication. Okay? And whenever you talk about radio communication, what is the purpose? Actually, any signal, is in the any information is in the form of an electrical signal or in the form of electromagnetic wave, and that signal is to transmitted the from the source to the receiving station, where a receiver or an observer will receive it. And so you can say that radio communication requires the transference of energy, or you can say radio frequency power, between the transmitter and the receiver. This is your transmitter, let us say T, and our aim is to transmit the intelligence or the signal or the information to this receiver end. Okay. So how this signal will be transmitted from this transmitter to receiver? That is the basic problem of radio communication. In fact, whenever you talk about such a communication system, basically this involves three intermediate phenomena. Okay. For this we require actually the different devices. Basically, we will discuss three important devices that are utilized for this purpose. The first one is called transmission line, another is called waveguide, and there is also a very powerful technique for this purpose, that is the recently developed optical fiber. So now in classical electrodynamics, our aim is to discuss these three devices for the purpose of radio communication or propagation of electromagnetic waves. First of all, we will discuss the device transmission line, after that waveguide, and finally we will discuss optical fiber. Okay. And the videos will be in accordance with the syllabus of different university of India, okay, and abroad too. So as you know, whenever I start a new chapter, first of all, I provide you a basic introduction, a brief introduction regarding that very chapter. So in the same manner, as we are going to start the chapter transmission line, so this video is intended only to introduce this transmission line to you. And after this introductory lecture, we will see the details of this chapter. Okay. And as I have told you, when you want to transmit the radio frequency power from the transmitter end, this T stands for transmitter, to the receiver. Actually, in this process, three phenomena takes place. Okay. And what are those phenomena? First of all, we will talk about the transmission line. In fact, the power which is to be transmitted, that is available at the transmitter output. If this is your transmitter, at its output end, the radio frequency power which is to be transmitted, that is available. and we have to release, we have to transmit this radio frequency power. Actually, for releasing this radio frequency power or energy into a space, it is necessary to feed it to some radiating conductor. Okay. Why we need it to feed some radiating conductor? The reason is that the disturbance and attenuation due to some factors. We will also talk about the different attenuation factors later on in this process of radiation, is not preferred near the transmitter location. And that's why, first of all, for the transfer of this radio frequency power from transmitter to radiating element, you have to feed it in radiating element. Okay. Actually, a device with minimum energy losses and distortion used for the transfer of radio frequency power to some radiator is known as transmission line. So you can say that transmission line is a device to transmit radio frequency power from one place to another. Okay. In fact, in order to avoid the disturbance which would occur if the transmitter and antenna are located at the same place, a transmission line with minimum loss of energy is employed between the transmitter and the radiating conductor, which is called antenna. Okay. So the second step is to release the radio frequency power or energy into space for the communication of intelligence or information. And for this, the device utilized is known as antenna. Okay. For this, transmission line is terminated by a radiating element. Okay. And the radio frequency energy modulated by the intelligence is applied to the radiator. Actually, the radiator sets up a high frequency current along its length, and the electromagnetic waves are produced into the space due to the escape of electromagnetic energy from the radiating element. This radiating element, which actually produces electromagnetic wave that is released in space, that is called actually antenna. So what is the process? Actually, when you terminate the transmission line to this radiating system, which is called antenna, then there will be a superposition of radio frequency wave and the intelligence which you want to in fact communicate, and that superposition is called modulation, and that modulated wave will set up in the radiator a high frequency current. Okay. And due to this setup of high frequency electric current, electromagnetic waves are produced, and that is released into the space by the radiating element, that is by the antenna. Okay. So this radiating element which releases or the electromagnetic wave in space, that is called antenna. Okay. Now the third step is the mechanism of propagation of electromagnetic waves. We will also talk about this propagation of electromagnetic waves. Generally, these are propagated as ground waves, sky waves, or space waves. Okay. So these are the intermediate phenomena in communication of the radio frequency power from the transmitter to the receiver. Okay. But first of all, we are going to discuss the problem of transmission line. Okay. So in this introduction, I will now talk only about the transmission line. Okay. In fact, transmission line, as I have told you, is a device to transmit radio frequency power from one place to another. Okay. And in order to avoid the disturbance which would occur if the transmitter and antenna are located at the same place. A transmission line with minimum loss of energy is employed between the transmitter and the antenna. Okay. In fact, now we will talk about the types of transmission lines. Basically, transmission lines are of two types. First one is called parallel wire transmission line. In fact, this parallel wire transmission line usually are of two types, namely 2-wire parallel line and 4-wire parallel line. Actually, the horizontal 2-wire parallel line and 4-wire parallel line are balanced to ground devices. That is, at a point of one conductor there is some positive voltage with respect to the ground, and then it will be balanced by an equal negative voltage at the corresponding point of the other conductor. Okay. So a 2-wire line in vertical configuration is unbalanced structure, because of which it gives rise to unbalanced currents. Okay. And the unbalanced currents are undesirable for the increase of energy losses. So basically, two parallel lines transmission line are utilized in practice. Okay. Now this parallel wire line is used at a frequency of the order of 100 M.Sc per second, and its characteristic impedance ranges from 100 ohm to 300 ohm. You should remember this data for your objective type question. Now the another type of transmission lines are actually coaxial lines. In fact, this is the best suited at high frequencies, and it consists of two concentric conductors separated by an insulating material. As you can see, if this is a conductor and this is another conductor, and both are concentric, okay, and the space between these two conductors are actually separated by insulating material, that is by the insulator, or you can say dielectric. Okay. And as I have told you that this is best suited at high frequencies of the order of 3000 M.Sc per second, and its characteristic impedance is low, and it is of the order of 50 ohm to 70 ohm. Okay. Now in this figure I have shown the equivalent circuit of length delta x of a transmission line. In fact, transmission energy is affected by high frequency at which the inductance of short length of a conductor and capacitances between short conductors and their surroundings become appreciable, and their effects intermediate at each point. Thus, instead of lump parameters, we owe transmission line their effect concept of distributed parameters. Okay. So actually, whenever you will talk about the transmission line, you have to consider the distributed parameters. It is a conducting wire, but this conductor has in fact resistance and inductance R and L. These are called actually the distributed parameters. When you talk about distributed resistance, let us say R, the transmission line wire form of some conducting materials, and this will have some resistance. This resistance, because of uniform size of wire, will be distributed uniformly along the entire length. Okay, and therefore it is called distributed resistance. Similarly, when the radio frequency current flows in the wire, a magnetic field is developed about them, and thus field offers a sort of resistance to any rise or fall of the line current. Since this field links the wire current, inductance is present, and this inductance is distributed uniformly along the entire length of the wire. Okay. So as the inductance impedes the flow of current, it should be assumed in series with the line resistance. So whenever we actually draw an equivalent circuit of a transmission line, you have to take R and L in series. Okay. But apart from that, in this transmission line there will be distributed conductance and capacitance. Okay. In fact, the input and output currents of the line differ and leads one to realize that there is admittance between the wires even though there is no apparent connection between them. This shunt admittance consists of two components. First is capacitance, you can see here, and another is actually the conductance. Okay. So this is actually the conductance. Okay. So you have to actually represent these conductance and the capacitance in parallel and connected between the two branches or two parallel lines. Okay. So in this way, whenever we will discuss the proper theory of this transmission line in our forthcoming video, you will have to draw this equivalent circuit to discuss its proper theory. Okay. In fact, the capacitance shunts the line and therefore called shunting capacitance, and the dielectric between the wires is not perfect, so a conduction current will flow between the wires. This conduction or the leakage path may be presented by a conductance between the wires. This is actually the conductance G. Okay. So this is the basic introduction regarding the transmission line, and now in the forthcoming video we will start to know the basic theory of transmission line. First of all, we will learn about the voltage and current relation on radio frequency transmission line, where you will discuss the different terms like what is characteristic impedance, okay, what is reflection coefficient, how the reflected wave is developed. All these things we will learn in our forthcoming video. Okay, thank you very much.